astronomical aficionados, and welcome to our virtual online interstellar discussion for the month of March 2025. Space news for the month has started strong as last Sunday, Firefly Aerospace's Blue Ghost lunar lander arrived on the surface of the moon, returning these images. Blue Ghost is only the second ever private spacecraft to successfully reach the moon's surface. The first was Intuitive Machines' Odysseus lander that touched down last February. There's a lot more to discover this month. Let's transport outside and look up. We arrive just a bit past noon. Facing south, we see the sun at not quite its highest point in the sky for the day. When the sun reaches its highest point next Thursday, the 20th, then it will hit bullseye at the point when its apparent path, the ecliptic, crosses the imaginary dividing line of the Earth, the equator, ushering in the March equinox, the start of spring for us in the northern hemisphere. That's the sun transporting past its sit to discover tonight's moon, appearing just beside bright Regulus, the dot at the end of the reverse question mark known as the sickle that makes up the head and front legs of Leo the lion. Regulus is the brightest star in Leo. Tonight's moon is in the waxing gibbous phase, meaning that its light is increasing. The next full moon will be this Friday morning, and if you view it at just the right time, it may appear red. Between the hours of 1:09 and 4:47 a.m., for us here in Danville, the moon will pass behind the Earth opposite the sun, resulting in a total lunar eclipse. Just like a moon shadow during a solar eclipse, the Earth's shadow during a lunar eclipse is divided into two parts: the fully shaded inner region called the umbra, and the outer partially shaded region called the penumbra. As the moon passes through the penumbra, it will appear darker as the moon is blocking some of its received sunlight. But as the moon passes through the umbra, it can take on a reddish-brown color that some observers call a blood moon. The moon does not actually change color, rather this is an effect of some of the sun's red light being bent around the edge of the Earth's globe by its atmosphere. March's total lunar eclipse will be visible from the Americas, Antarctica, northeastern Russia, and Africa. On the 23rd, something that will not be visible from Earth is Saturn's rings. That Sunday, the second largest planet will be at conjunction with the sun, making it difficult and dangerous to spot with unprotected eyes. But the use of the right telescope and filters will produce a view of Saturn where its rings have appeared to disappear. This optical illusion is called a ring plan crossing, during which the rings appear edge-on or flattened thin to observers on Earth. Saturn completes its orbit of the sun every 29.5 years. During that orbit, the angle of Saturn's rings relative to the sun varies by 26.7 degrees. During that variation, the rings appear edge-on to the sun, producing a Saturn ring plane crossing every 13 to 15 years. A change in perspective reveals the rings are still there, at least for now. Some NASA scientists predict that in the next 100 to 300 million years, that the rings of Saturn will go through an experience called ring rain, when the planet's gravity pulls the rings apart and vaporizes their icy chunks in the upper atmosphere. Saturn's inner rings would go first, followed by the outer. 300 million years is a long time involving a very slow process. Saturn's rings disappearing quickly would require something with a lot more gravity, something like a black hole. Like the one at the center of our galaxy. Sometimes, when large stars reach the end of their life cycle, they collapse in on themselves, condensing their mass into a comparably small volume, resulting in incredibly dense stellar objects called black holes. Black holes are so dense that even light cannot escape their gravity, making them difficult to study. Nevertheless, one American astrophysicist has made the study of black holes her life's work, and she received the Nobel Prize for it. Current astronomy and physics professor and chair of UCLA's Galactic Center Group, Andrea M. Ghez, has spent decades observing the stars at the center of the Milky Way Galaxy. By studying their orbits, she and her team were able to determine that the stars are moving around a supermassive compact object now identified as Sagittarius A star. Normal black holes can reach 10 to 30 times the mass of the sun. Sagittarius A star is more than 4 million times the mass of the sun, all crammed into the space of roughly half the diameter of Mercury's orbit.
I think black holes, because they're so hard to understand, is what makes them so appealing. This idea that they're objects where that represent the breakdown of our understanding of the physical world, and where you get this mixing of space and time for me, those are the things that intrigue me about black holes. The fact that they were so hard to understand, and that these things that we take for granted become so difficult to understand. This idea that space, which we experience as humans as separate from time, become commingled. It's both intriguing and fascinating, and I have to say these are the things that kept me up at night when I was a kid.
For her contributions in 2020, Ghez received the Nobel Prize in Physics, the fourth woman to do so, joining the legacy of Marie Curie, Maria Goeppert-Mayer, and Donna Strickland. Thank you for joining us for this month's discussion. We'll see you the second Tuesday of next month, Tuesday, April the 8th. Until then, thanks for watching and keep discovering. Bye.